From Double Dare to Ghostbusters to 1 hour oddly satisfying slime ASMR, everyone loves a good slime. Just not when you want a nice, relaxing day at the beach. Actually, one of Ghostbusters' big dirty secrets is that in real life, large blobs of slime can wipe out an entire ecosystem, destroying fish economies and can cause you to get violently ill, even to the point of death. And so here we are again with Space for Humans, where we want to talk about how space technologies can help protect you from giant blobs of slime. I'm Chris Langendorfer, and this is Slime Blobs from Outer Space.
Space for Humans.
Space for Humans. You may recognize it as the green goop growing in your fish tank, chlorophyta, the green stuff around your sushi roll, seaweed, or the health supplements in your Jamba Juice, spirulina. Yes, that's right, it's algae. And algae occurs naturally in water, but when the nutrients in a body of water are just right, they can bloom, meaning that they go into reproductive hyperdrive and create a slimy, smelly blanket across the surface of the water, thus forming harmful algal blooms, or HABs, which is, as the name suggests, harmful. Despite what the name suggests, HABs are not always technically algae. Regardless, a harmful algal bloom coats the surface, blocking sunlight from reaching the plants below, killing them, and causing a chain reaction across the ecosystem. As the algae decomposes, it uses up available oxygen in the water, thus asphyxiating fish and other marine life. If a local economy is relying on fishing, these blooms can have devastating economic ramifications. One such cyanotoxin is microcystin. In high doses, microcystin can cause gastrointestinal illness, liver hemorrhaging, and death. In extended exposure to low doses, it can damage the liver, kidney, heart, reproductive systems, and lungs. In nations without proper water treatment infrastructure, drinking water collected from algae-rich rivers and lakes quickly become dangerous. Now, not all algal blooms threaten humanity or the ecosystem in which they occur, but some do. In the summer of 2015, a massive HAB of Pseudonychia bloomed, spanning from the middle of California to the Aleutian Islands in Alaska, devastating the shellfish industry and other marine life. HABs can also devastate sensitive ecosystems, such as coral reefs, which do not recover from being smothered. HABs are also one of the leading causes of oceanic dead zones, aquatic regions that have oxygen levels too low to support marine life. And while a natural phenomenon, HABs are increasing in both number and size, both as our climate changes and as natural ecological systems are disrupted and polluted. Algae thrives in warmer water temperatures, and algal blooms form when nutrients such as nitrogen and phosphorus are overly abundant. These nutrients are byproducts of fertilizers and runoff from farms and industrial plants. Poor waste disposal can also cause increased levels. While the issues surrounding HABs are complex and difficult, satellite monitoring is making an important impact in identifying and observing new blooms and conducting scientific research in oceanography that will allow us to better understand the problem. The National Oceanic and Atmospheric Administration, NOAA, currently uses satellite data to detect these algae blooms and warn local populations, saving people and hospital bills. Satellites identify the chlorophyll A present in algae, thereby highlighting algal blooms. Once HABs are spotted, the local government can issue warnings to caution people from boating, swimming, and instruct them to fish safely. This response can drastically cut down on illness and the resulting healthcare costs. This was demonstrated in Utah in 2017, where an estimated $370,000 was saved in medical bills. One extremely interesting development in studying HABs comes from South Korea. Reoccurring HABs around South Korea pose substantial risks to local fisheries, aquaculture, public health, and the economy. In June of 2010, the Korean Aerospace Research Institute, or KARI, launched a geostationary ocean color imager, or GeoCI, a geostationary satellite specifically designed to monitor ocean health around the Korean peninsula. One of the primary justifications for this satellite was the monitoring of harmful algal blooms. GeoCI was designed to observe specific wavelengths that allow it to differentiate between different algae species and effectively track and analyze the development and spread of HABs in the region. Developments in satellite remote sensing are allowing us to both understand and quickly respond to harmful algal blooms, and it is one more way that space is preventing Aquageddon, the fish apocalypse, slime blobs from the deep. Remember to like, share, and subscribe for more Space for Humans.